Hello, the video you are watching is about multiple ways resistors connection. Actually, we are going to have a characteristic example. We have this the sketch of this circuit, and we suppose we have these values, and we need to calculate the total resistance, the current passing through the voltage source and every resistor, the voltage drop across every resistor, the power dissipated by a resistor R3, but actually we are going to find every every value for every quantity. Okay, let's get started. What are we going to do? How we are going to cope with this kind of exercise? We are going to create an equivalent table. What do I mean? Let me show you. We have here the sketch of the circuit. We are going to create this table where we have R, V, I basically, standard. R, V, and I. The P is not so important, but R, V, and I are very important because they are used in the Ohm's law, which is the base of our calculations. So I put RVI. I also write here 1, 2, 3, every value, every resistor, okay, every resistor and every combination of resistors. I have R1, R2, R3. I have the combination now of 2 parallel to 3, and I have the combination of the 1 in series with the 2, 3 packet. Okay, after I'm going to put the values. R1 equals to 4 ohms. R2 equals to 18 ohms. R3 equals to 9 ohms. And as I can see, the voltage source uh, gives me a voltage of 200 volts to of uh, all of the circuit. Okay, now we are going to ignore the sketch that we had, and we are going to fill the cells of this table. It's like a game. How am I going to handle it? I have the two parallel to three, which means these two are going to have this formula to be calculated. I'm going to find R23 from by this formula, and I will get number 6. 6 ohms is the value of 2 and 3. Be careful here. I want to make a notice for you, which is that this formula here, the R23 that is equal to R2 times R3 above R2 plus 3 is only for two parallel connected resistors, not for more. The basic the basic formula is this one. 1 above R total equals 1 above R1 plus 1 above R2 plus 1 above R3 plus and so on and so on. Okay, this is the basic formula for a parallel connections combination. Okay, not this one. This option is for 2. So let's continue. I have found the value of 2, 3 parallels packet. This is the equivalent sketch. Okay, and we continue with the next one. I'm going to find their total. I'm uh, following an horizontal direction here for my calculations. Their total is the sum of R1 plus R23, okay, it is 10 ohms because it is in series. And here we have now the equivalent sketch. Now, how are we going to continue? We go vertically here and we see that we have 10 and 200. we have the two values of V and R, and we can find the third one. If I have vertically in a perpendicular direction, okay, if I have two of these three values, R, V, and I, if I have two of these three, I can find the third one. So that's what I'm going to do. I equals to V, because I am here, be careful, I am in the total, I use Vs above R total, which gives me 20 amperes, and I will put it here. Okay, I have found the R, the V, and the I in this way. How am I going to move on? I see from the R total that I have some properties for the R total. What do I mean? I have the resistor 1 to be connected in series with the packet of 2, 3. So these two resistors, the R1 and the packet of R2, 3, have the same current flowing through them. So I will put here 20, and I will put here 20 also. You see, the R1 and 2, 3 have the same value of the current. So here again, I have two of the three cells, okay, that I need, and I will find the third one. It's a game. V23, it's 6 times 20. So I get 120 volts. Here it is for the V1, 4 times 20 gives me 80 volts. And that's all for now. Now, how am I going to fill these cells? I have only one value here and one here. I want to have two somehow. Now I'm going to get information from this packet of total resistors, 2 parallel to 3. What do they have? They have the same what? Okay, here I have an alternative option for calculating the 80. Okay, we have the V1 to be Vs minus V23. Okay, and we get also 80. As I was talking about the 2 and 3 properties now, I have the 2 and 3 to have what? The same voltage, because they are parallel. This symbol shows me that they are in parallel, so they have the same voltage. So 120 here and here. So I fill these two cells. So I have again 2 from the 3. It is very easy to calculate now with the Ohm's law the last cell. V above R, V2 above R2, V3 above R3, and we get these two values, 20 above 3. So you see it's a game. Okay, this is the basic concept. After we are going to find the P from the V times I and so on. But the basic is to find these values here to fill these cells. Okay, you can see the video again in order to understand what happens. Okay, so I continue now with the P1. Here I have everything. I have many formulas for the power, and I use one of them, V1 times I1. So I get from this multiplication, the product is 1600 watts. Here I have for P2, V2 times I2, 800 watts. Okay. For the third one is V3 times I3, which is 1600 again. And now for the total, the P total is the sum of every power for every resistor dissipated by every resistor, and I get 4000. I can get it by, as you can see, the multiplication VI times I, V times I here to the total, to the, okay, which is 4,000, but we can make the addition also of every value 1,680 plus 1,600, we get the same result here. Okay, so this was a characteristic example. See it again and again. It's like a game. And don't forget, not don't remember, don't forget that even if we get all the knowledge of the world, if we do not have love, we are nothing. Keep on studying.